Next problem in difference of two mean test, right? In a survey of buying habits, 400 women shoppers are chosen at random in supermarket located in a certain section of a city. Their average weekly food expenditure is rupees 250 with a standard deviation of rupees 40. For 400 women shopper chosen at random in a supermarket B in another section of the city, the average weekly food expenditure is rupees 220 with standard deviation rupees 55. Test at 1% level of significance whether the average weekly food expenditure of two population of shoppers are equal. So here we are taking two groups from two supermarket. First supermarket located at one area, that is A, let it be, and another supermarket in the other area, let it be B. So we are we are taking the sample of buying habits of women, right? First they have chosen the supermarket A and they are asking 400 women, right, who are coming to purchase something in that supermarket. So their food expenditure, right, they are asking only particularly about the food items, right? Food expenditure mean, right, 250 and the deviation, right, one to other, right, that is 40. Next in the B, supermarket B, similarly they are asking the same number of women. So in that they will collect the mean, right, is 220 food expenditure mean, right, and standard deviation 55. Now we have to check the the significance of whether the food expenditure of two population of shoppers are equal, both are same or not, right? So given sample size n1, n2 both are 400. Sample mean x1 bar 250 first supermarket A and x2 bar supermarket B 220. Standard deviation supermarket A s1 equal to 40 and supermarket B small s2 is equal to 55. Now defining hypothesis H0, there is no significant difference. We are taking both population shoppers are equal, right? The expenditure of the two population shoppers, that is supermarket A and supermarket B, both are equal, right? Alternate hypothesis is just opposite to H0, that is mu1 not equal to mu0, that is two-tail, right? We are taking two-tail test. So given level of significance 1%, test statistics z is equal to x1 bar minus x2 bar by root of, here small s1 s2 they have given, that is why we are taking s1 square by n1 plus s2 square by n2, substituting the value 250 minus 220 by root of 40 square by 400 plus 55 square by 400. After simplification you will get 8.823. Therefore calculated value of z is equal to 8.823. Now we are going to take the tabulated value. So table value at 1% level, that is 99% of significance, that is confidence, right? So at 1% level of significance is 1%, then the value tabulated value is 2.58. Comparing tabulated and calculated, obviously calculated value 8.823 is greater than 2.58 tabulated value, therefore H0 is rejected. Therefore there is a significant difference. So the average weekly food expenditure of two population of shoppers, that is market A, supermarket A and supermarket B, are not equal, right? So next problem, the average hourly wages of a sample of 150 workers, right, 2.56 with standard deviation 1.08. The average wage of sample of 200 workers in plant B, first plant A, next plant B, that is 2.87 with standard deviation 1.28. Can an applicant safely assume that the hourly wage paid by plant B are higher than those paid by plant A. So daily wages, hourly wages, right? Here we are calculating. First, they are taking 150 workers from plant B and 200 workers from plant B. Sorry, 150 workers from plant A and 200 workers from plant B. So two part in a factory, right? First part, that is 150 workers they are taking as a sample and asking for that the hourly their wages is 2.56, that is the average, and the deviation is 1.08. Next they are going to part 2, second building in that factory. So they are asking for 200 workers, sample is 200, then they get the average 2.87 daily, that is hourly wages, right? Deviation is 1.28. So n1 equal to 150, n2 is equal to 200. Small n1, n2. Sample means x1 bar 2.56, x2 bar 2.57, and s1 is equal to 1.08, s2 is equal to 1.28. Defining hypothesis. So there is no significant difference between both the plants, right? We are taking like that, right? So h1, just we are taking the two tail mu1 not equal to mu2, right? So let here you can take higher those paid in plant A. So mu1 is less than mu2, you can take left tail also. Otherwise, if you are taking mu1 for plant A and mu2 for plant B, so the plant B workers hourly wages is more than plant A. That means mu2 is greater than mu1, right? So mu1 is less than mu2, that means you can take left tail also, that is what, right? So we are taking two tail test. Level of significance 5% we are taking, they have not given, so we are just assuming. Test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. So substituting these values, 2.56 minus 2.87 by root of 1.08 square by 150 plus 1.28 square by 200, you will get minus 2.423. So calculated value is, you are taking the modulus value, so 2.428. Then tabulated value we know for 5% level 1.96. So clearly calculated value is greater than tabulated, therefore h0 is rejected. So there is a significant difference. That means the wages, hourly wages paid by plant B are higher than those paid by plant A. Right? You can take left tail test and you can calculate, right, as it is same, but you have to take the table value for left tail, not two tail. That is the thing, right? Next problem. A simple sample of heights of 6,400 Englishmen, right? Their height, Englishman height is 6,400 sample, right? First Englishman, their sample height 67.85 inches, standard deviation 2.56, that is x1 bar and s1. The second one, they are taking 1,600 Australians, right? n2 is 1,600 and their mean height 68.55, that is x2 bar, and standard deviation s2, that is equal to 2.521 inches. Do the data indicates the Australian are on the average taller than Englishman? So we have to check Australian are taller than Englishman, right? So defining hypothesis, there is no significant difference we are taking, right? So h0 mu1 equal to mu2 and h1 two tail test mu1 not equal to mu2, right? You can take, if it is mu1 is Australian and mu2 is Englishman, so you can take mu1 is greater than mu2. You can take that right tail also, right? Right tail test. Level of significance be 5%. Test statistics z is equal to x1 bar minus x2 bar root of s1 square by n1 plus s2 square by n2. That is equal to 67.85 minus 68.55 root of 2.56 square by 6400 plus 2.52 square by 1600. So after simplification you will get minus 9.8592. So calculated value is the modulus value, that is equal to 9.85, taking the positive value only, right? So 9.8592. Tabulated value at 5% level, that is 1.96. So conclusion, calculated value is greater than tabulated value, therefore it's not rejected. So Australians are taller than Englishmen, right? That is the conclusion. Thanks. You can try on the right tail also in this case.